Hello all. Today I will be explaining the pick and place operation using rows. This is a third part of simulation of robotic arm videos. So please go through the previous videos if you don't have a Moveit package for robotic arm. So continuing from the previous part, to spawn the robot model in Gazebo, ros-launch package name gazebo.launch. So this is opened. Then in another terminal, launch movegroup.launch. So we can start our planning now. In another terminal, launch moveit_rviz.launch. Change the fixed frame to base link, add robot model and motion planning. Then save this configuration file, save configures. Create a folder Rviz inside the Moveit package and then save the file. Okay. So we are trying to give different poses, planning and executing them. So we have selected the pick pose. So take a cube from Gazebo environment and then resize using this button. After resizing, place it inside the open grippers so that we will be able to create an object having a relative size of the gripper. After resizing it to a small object that occupying inside the gripper, move the object to the open gripper. You can make use of different options available in Gazebo, like the move option, scale option, rotate option, etc. And there are different type of objects also, cube, cylinder, spheres also. We can insert models also. To change the color of the object, right click edit model, right click open inspector, green to 1. So we will get a green object. File, exit link inspector, save the model. It will be saved to the models. So remove the robot model and save the world inside the world folder in the Moveit package. Normally in gazebo.launch, empty world will be spawned. So change the name of the world to the name that we have saved now, so that the robot will be spawned along with the world having the object positioned in the pick pose. Previously, we have launched the 3 launch files in 3 separate terminals. For simplicity, we are giving the 3 launch file inside a launch. So, from now, we just need to launch this file, roslaunch package name computer_script.launch. So, we will get the gazebo.launch, the move group and the Rviz visualization. We have saved an Rviz configuration during the initial setup after giving the robot model and fixed frame etc. to Rviz. We have saved a config file. Give the name of the .rviz file here. So type roslaunch package name computer_script.launch. Gazebo will be opened, move group will be launched and also the Rviz visualization will be opened. Since we have given the object in our world, the object is also spawned with the model. So we are going to try pick and place object by giving different poses using Rviz. Select the after pick pose. This is the after pick pose. Then give the pick pose. Then change the planning group to gripper group and then select the pose for closing gripper. Change the planning group to arm group and then give after pick pose so that it will lift. But the problem is the object slipped out of the gripper. So we need to solve this issue using a plugin. For that we are using Gazebo Grasp plugin. this is used for simulation of pick and place operation by a concept of attaching and detaching from gripper. So our next step is to add the Gazebo Grass plugin to the URDF of this robot model. Paste the Gazebo Grass plugin here. So we need to set some parameters. Give the name of the wrist link to the palm link. Give the name of the two fingers of the gripper, that is finger 1 and finger 2. In my case, wrist is link 6, that is the last link of my robot. I will provide Gazebo Glass plugin and the reference for the plugin in the description box. There are also some other parameters which can be tuned like detaching time, etc. So we need to install all these dependencies. Sudo apt-get install the 4 dependencies and then change directory to the workspace src and git clone the 2 packages, gazebo message package and gazebo packages.git. After that, build the workspace. I will show the steps quickly. Melodic is my distro, so I am installing the 4 dependencies. To continue, type Y and press enter. Next, change directory to src. Copy the first .git package and then clone it inside cat king workspace src and also clone the second one, gazebo packages. Okay, the 2 packages are cloned to the workspace and then we need to build the workspace. So type catkin_make inside the catkin_ws folder. If it is success, proceed. If it is success, we can see some green indications like this. So the build is completed now. It will complete in a second. Launch the robot model along with the Moveit group and Rviz again. For that, roslaunch computer_script.launch. It is loading. So Rviz is opened, Gazebo is opened. If grass plugin is fine, we can see some lines in green color inside the gazebo.launch or computer_script.launch. So arrange the windows so that we can see the gazebo screen and Moveit screen simultaneously. Then we have selected the planning group as arm, so we can give different poses of arm. So first we are giving before pick pose, before pick and after pick pose are same, so I am giving after pick. Then planning and executing the second pose, that is the pick pose. And third pose is closing the gripper, so selecting planning group as gripper and goal as close. Planning and executing. We have closed the gripper, then we need to lift the robotic arm up. For that, select the after pick pose from arm group. So the object is successfully picked. This is because of the Gazebo Grass plugin, otherwise the object will fall out of the gripper. So we are going to place it. For that, take planning group as gripper, give goal state as open, then execute. So the object is detached from the gripper. You can check the terminal for seeing the attaching log and detaching log. I will show you an application case of Gazebo Grass plugin. Normally this is used only for simulation. This plugin is used only for simulation. This is a project of my friend, which is a shopping assistant robot. Through Python script, we are going to different points and opening and closing gripper, and we have also given the Gazebo Grass plugin. So the arm picks the object, then move to the place point, and then opens the gripper, so that the object will detach from the gripper and falls down to the plate. This is one application case. I will show you another application case, which is a feeding robot. This project is done by two of my friends, and this is a simulation video. The robot will detect the lip of the person and then compute a point. Using move to a point program, the robotic arm will move to the particular point. The robotic arm takes food from the bowl and then move to a point, which is the point computed after the lip detection of the camera frame. So the robotic arm feeds food to the man and then go back to the initial food collection point. Then again computes the lip detection point and then feeds the man. Thanks for watching. See you in another video.